Yeah. So good evening, everyone, and welcome to this today's session of Saturday Talk. We have Shri Sudarshan Natu ji today with us. I'll give a brief introduction of Sudarshan ji. Sudarshan ji co-founded Lethal Computer System Private
You can
Limited,
just say Sudarshan, that's all. Remember.
and he was also worked as ex-vice president of Herman Connected Services, a division of Herman International. Now it's a fully owned subsidiary of Samsung Electronics.
Hope you are able to see.
Yes, sir.
Yes, sir.
So primarily what I intend to do today, as we set up a company in the VLSI domain, way back in 1993, I wanted to share that as a journey. And as I understand, all of you are actually also kind of a startup company doing excellent technological product development, innovation, innovative product, and the young mindset which is working with senior folks, creating a synergy. I thought maybe narrate this particular story. So VLSI is just one particular aspect. But VLSI, you can imagine way back in 1990, it was not heard kind of in those days, the electronic design was done purely on at least in India, on an annual basis. We used to actually design CPU-based products, raw circuit diagrams, schematic, everybody data sheets, and design a product, write software, hardware with what are the limited. And I did develop actually many products, 82 to 92 in his decade, in that particular fashion. And that's why this opportunity came. I was really actually really excited. So as we are talking about an entrepreneurship, you know the various definitions of entrepreneurship. I like this as the most because it really actually narrates and actually goes to the heart of the engineer. The entrepreneurship is a manifesting ability or willingness of individual. We might be in a team, we are working within an organization, outside organization, and every person actually who is creating new opportunities, new products, methods, and actually helping an organization to grow, I treat him or her as an actual mentor. Because in today's technology, not only that, and one person can enter into this, invest his money, time, and everything, and other people come and work together as a voice. Today's era actually demands every and each one of us actually to contribute in every aspect of the business. That's why I like this definition more precisely than a standard definition of saying that a person who takes ability. I think that's whole definition. Surprisingly, this definition was also actually put forward in 1990, way back, and this is coming very much true and the necessity.
So when this opportunity came, and I was also curious enough to know how actually the designs are done and how entire design is first evaluated, how it is done on a breadboard or rather on a computer-aided design, and then actually venture into that. And then all this started because Nital Consulting Services, which was founded by Nitin and Alaka Sarandar in 1990 in Portland, USA. They are my relatives, they are my sister and brother-in-law. And they saw this opportunity because they were very much there in Portland where actually Intel is closely working, where the new era of actually VLSI, VHDL, these kind of languages were coming up and picking up. And so they saw an opportunity, and the thing which was required was a person actually who understands actually the technical aspect, design, who can actually understand it, may not have used those design, but that was actually the necessity for us. And we all being a technical people, we decided actually to enter into this cutting edge technology, even though we just didn't know anything about it. And it was unheard of this in 1992. So we set up actually in 1993 Nital Computer System as 100% software export unit, because primarily even though it's an hardware design activity, the VLSI using tool is purely a software activity. And that's why we set up actually software in the part. And later, after about 10 years, people realized that the hardware parts also actually came up. Hardware export parts were specifically designed. But our activity mainly focused in 1993 from a software point of view, and we are the pioneers. So we actually decided to focus on DA design verification services primarily. Then that time the serial bus connectivity, the designs were coming up, technology were emerging. And so we decided to actually do that. And then based on that, our past experience, hardware design, embedded technologies was a core forte. And I'm really proud to say that VLSI domain in 1993 it was unheard, at least not in Maharashtra for sure. Hardly might be in any good traces there, and might be in Bangalore as such over there, because the TI was there that time, just started. But we are the only company in Maharashtra where we actually started up. So we had actually initial problems, but we started with only 5 of us, Nitin and Alka being in USA. Nitin himself is actually a technical person. He worked with Intel. In fact, he is one of the actually team member with Vinod Dham to do Intel Pentium Pro chip. And our first actually the IBM's IBM PCXT. He was Intel's architect on IBM PC platform. So he has got actually that experience, expertise, and then that's why the opportunity actually came up. Alka also actually IIT graduate. We are all actually IIT graduate. So in those days we established actually the Texas Instruments, IEEE 134 Trade Association membership. Texas Instruments actually acknowledges the IEEE 1394 partner in there, because this particular technology was only short-lived, because Intel came up with USB and USB higher speed. But in those days, in 1994, this technology was working at 200 Mbps per second. So that was the rate at which it was working. But somehow actually the industry was taken up with USB 2.0 with Intel's push. Then PCI SIG member we became, USB SIG member we, Intel partnership, Xilinx Alliance partner for PCI Express and IP evaluation. So we created actually the success story in our journey as well. So I'll just show you what exactly some kind of a hardware product case studies where this VLSI is actually practically utilized. This was our actually first USB bus analyzer, and this bus analyzer actually what it does, it actually sits between the two boards or any particular board, and it was also based on VLSI as a Altera FPGA. And it will capture all the signal which is running on USB 2.0. Nowadays you just connect a USB, but for example, if you connect a USB pen drive and you just wanted to see a file system, actually moment you connect the USB and try to see a file or file location and everything, millions and millions of transactions actually they take place. So at a lowest level to the next level of data link layer and next layer of abstraction and then the protocol layer and everything. And then they form, and then beyond that actually the operating system's device drivers comes into the picture. So you need to actually sit down and actually find out if there are any issues. Nowadays you won't see this is being utilized because the technology is so stabilized, you blindly utilize it. But imagine when there is and still today also, when you are developing a new USB product or something, you need to create your own, you can say that endpoints, so that you can define your product properly. You can define your own properties, so it can be provisioned properly. All that is still needed, but it has become a kind of a stabilized technology, I would say that. This is actually PCI into 4-lane PCIe exerciser. This is so you can imagine this the next version both the same. But you can imagine this 2003 2004 period, we developed actually this particular board, which is highly complex, high-speed design board with surface mount technologies. Complete board design here is a multi-layer board, in-house development, and the entire IP which was developed by us. So all these products are actually utilized using a VHDL or Verilog as a language which describes hardware. So how exactly we define an hardware in terms of your schematic diagrams and everything, we write exactly the same functionality in the VHDL Verilog language. And then we synthesize with the tool. And after synthesizing it, depending on a target ASIC or the chip or the technology, it actually, you need to see that the timing and everything matches perfectly, and it works at what the desired frequency and the speeds. So this is a board we developed this thing, and then this board was actually used by almost all people in the world to first do a prototyping of the IP. The soft IP they will modify it, because you are, say for example, you are developing a like NVIDIA kind of an interface, which is actually also based on PCI Express as a bus. Today almost all your PCI Express is a standard de facto thing in your laptop, PC, everywhere, because that is where a high-speed bus comes. And today actually into 16 lane, each working at 5 gigabits per second, and that is a throughput you need it in today's time because of AI and everything in the GPUs they are working. But these were actually the basic technology which was actually going in those days, and this is how actually the technology takes place. This is the bigger brother of that into 8 lane, so it's not only 4 but 8, and then actually the technology emerged, and then we developed this another board with another capabilities, so that this can be actually used, and this was sold as a endpoint. So what happens by this time, the people started developing their own IP boards, everything. and they needed to be certified, because somebody has to certify whether it is working properly or not. And then the person will sit and insert their board, and then we will run the diagnostics on this in the top of that, and then it will execute all the sequence, and it will generate any kind of error conditions on that, and then your IP needs to be certified. So it's a de facto validation of your design in a real time is to be done by this board. So this was actually used by many companies in the world, the big names, because this was considered as along with the tools and the software, we developed actually scripting languages along with that, and the entire suite was to be actually developed. And all this actually happened from India, by the way. There's no team in US used to do that. The entire thing actually happened in Pune. This was actually smart security board for this was for a defense this thing. So I won't go much detail, but there is an additional board which goes on the top of that, which will connect with actually a specific interface. And so the secured communication for military applications, this was done for the ECIL those days, because we were contacted by ECIL, DRDO, NAL, everything, because whenever they used to go and contact companies like Xilinx and other people, they used to divert it to us, saying that these people are sitting in Pune and they can actually help you instead of you connecting back and to us in the United States. So this was one board. This is another actually Xilinx optical. So this is actually the 16 3.2 gigabits Rocket IO boards, and these are practically connected for connecting supercomputer building blocks. There are 16 the different computers will be actually connected with optical fiber links along with this particular board, and you connect a multiplexer switch so that the data and the traffic can be pushed onto the another one, and then you can do concurrent simulations and concurrent actually the algorithm development, and then collect all the data and actually predict it. So this is also actually used for some kind of a defense application and some weather applications and everything over there. All the custom kind of boards. So this was just a snapshot of the whole thing actually what I did. So practically like since 1993 and how I actually went back. And so in 2008 we actually merged with Core Object as a company with my team, because we decided that time Synopsys actually wanted back our entire team to be taken back to Bangalore because Synopsys wanted to enter in India by that time, and then we didn't want to for some reason, and then we just stayed back, and so we transferred that technology. In fact, Synopsys acknowledged after 15 years of the entire relationship, we could train their entire people, set everything, and go back, and then so that's also actually demonstrated, saying that the technology which was acquired by us and retained by us for 15 years, we could deliver it back to them successfully. And they actually acknowledged that with an open letter to us as well. Then the Core Object got acquired, then Symphony became Symphony Harman. And primarily, I joined with them so that with the hardware design experience, the end-to-end product development experience, the company actually ventured into hardware. Otherwise, these companies were purely a software company doing in databases and web design and everything. But this company's goal was actually to venture something into hardware. So we developed many products actually later on. In fact, my team then used to do actually many products for diagnostic one, wearable devices, embedded complete products. We actually worked for another company for almost about 25 years for Data IO, which actually the world's best programmer in the world. Every programmer or every programming IC what we use in the world, the Data IO actually provides the programming for that. And we used to be de facto programming house supporting from India. So now I'm just working as a professor practice and then doing that. So enjoying my life. But what I would like to say as a team, the technology, when you are actually creating this particular technology, it doesn't happen in actually vacuum. It's a complete team effort. Every team member you need to take along with you. You need to train people. They need to actually be sensitive about all the information, retain it, and I'm very happy that actually I inculcated a practice saying that if somebody came to me after a huge this thing, they will also go back, and when they leave the company, their job is actually to touch another person who is coming in, give a complete training, and continue the chain. And my people actually responded, and I really take pride in doing that. When people still comment saying that what they did, learn, and everything in Nital, and that's how actually it went back. So like with a practically no business background, just from a family point of view for all of us. And then we ventured into that as a complete team, created new technology, new domain, and there's no mentor in such areas. But we actually work together and try to do that. So running up a company, hiring employees, managing finances, governance and everything, custom, excise, all kind of thing. And I'm sure I don't have to know, Rajesh and everybody would know that. But why I'm just narrating this, because this can be everybody's this thing, every employee, everything, every person will have dream. And as I said in my first initial slide, your entrepreneurship begins wherever you are working at. Because I took every opportunity to work in my first 10 years also, understanding how the companies are run, what they do, what kind of challenges they face, and be sensitive to that. That's why actually, even if my short stint is a very small SSI company, I could actually learn a lot, take it those learnings and ensure that I do not create those kind of a mistake and actually learn something new and create a successful team technology. And with that, actually, I'd like to stop, and I would just say that whatever your experience, just reflect it, add to that, keep on adding something new, and the growth is there for everyone. So if I got any technical as such as a question, then definitely I'm a core technical person. I still do development. I still do actually software programming, hardware designs. Even if in the COEP we established a complete state-of-the-art now assembly line for electronic manufacturing here, so that we can train the next generation. Apart from that, I just keep myself very much occupied with trekking, going swimming, cycling, and whatever I can just enjoy over there. And recently, I actually registered for the PhD also. Even after developing all these products, I wanted to take a test of how academically people actually they keep doing a research in a formal way, and how they take the journey over there. So I just interested in learning that. So just trying to take that. So thank you so much for giving me this opportunity. I didn't want this to be a pure technical session as such, but I can take technical questions, whatever it comes to your mind. And if I got some kind of experience or exposure over there, I'll share my thoughts on that. So thank you so much.
Sudarshan, Harish Pathak here. I was told by our common friend Shirish Majumdar. Actually, Shirish and me are close buddies. He told me to contact you for this talk today. And he also told me that in 90s, COEP students, when they passed out, their first dream was to join Nital.
Yeah,
and
true.
If they got a job there, their dream was fulfilled. And after that, they would migrate to USA with a huge experience gained from this company. Is that true? And how did you achieve that?
Absolutely true. In fact, actually, there's so many people there in and around industry, the renowned industry today and outside as well. And they really came from various small in and around villages, colleges. Is to select them, not looking at their just as a strong bio, but what they can really do, what they can learn. And because we learned all this technology is new. So if these people can learn, then we are sure that anybody can learn about it. So they responded, and really true. That's quite true. Even if sometimes I do meet people today, even though they were not employed, and when they tell me, "Oh, Nital, in fact, that was a dream company. We came for an interview, but you didn't select us." And then I had to tell them, saying that, "Oh, it was good because that's why you are here now." And you are doing something. So thank you so much.
Sir, good evening, sir. This is Prithvi.
Hello, Prithvi.
Thank you very much for the session. I am an electronics and communication student who turned into a UI UX digital designer.
Good.
So I wanted to get into electronics then, but based on your talk, as someone who is interested in entrepreneurship, can you give an overview on how did you acquire customers? Because there are these huge customers where they're easy to acquire. What was the process of they knowing the company exists, and how easy was it, or what were the challenges?
Yeah, I think certainly I can narrate my experience from Nital and beyond that as well. But I think it's good actually. We are doing actually UI UX. That's an important aspect of any product. And I can tell you that you coming from the electronics background with that understanding, even if in whatever you represent, whatever you design, even if you trace it back to the core inside over there, your designs will be so robust. It won't just need a change, because you look at very differently. So if you keep that aspect, I think you can really enjoy it. That is, I can definitely tell you, because this is that's the front end kind of this thing. So it's very, very important, very crucial one. So keep up that work. Second point, actually, what you said is acquiring of these customers was huge challenge. In those days itself was very, very difficult, to be very honest. But what we used to do, our model was very different than actually the kind of a sales model, going pitching and then technical. Later on, we started doing that when the company became very large in Harman and everybody, because it was 7,000 people, so it was very huge. But when it was core technical team, when you are working, acquiring customer is based on actually how you relate to your customer, how you give your confidence to your customer in terms of how you understand their problem and your confidence instead of just overcommitting it. And whenever we went to this customer, they really realized that actually we are the people who can understand it. If we are not an expert in that particular technology, these people have demonstrated that they can acquire, they can deliver it. I think that has a lot more thing in a high technological area. While if you've got a standard product and if you want to sell it as a suit and you've already done it, then there are many different things. Then you need to actually go and do a lot of training, see that actually can it be proliferated to the lower level person. Your sales team will work on, your marketing will actually take collaterals, and so it's a standard way like what people will do. For a technological and to build kind of a team, there is something else also has to be there, and you need to get technically involved. So for example, when we used to get acquiring as a customer, myself, Nitin, Nilesh, we used to put our time on that. We used to practically give our consulting to them initial phases, and then they used to give a confidence saying that, see, this is what I am doing it, but I got a team in the back in India. They can do much better wonder because I am only one person, but I can give you leverage of the multiple of it. Maybe yes, my experience and their experience, there is a huge gap, but me going back and actually leading this and doing that, it will multiply it for you. And after giving the initial confidence to them, they used to be comfortable. Naturally, the challenge in terms of expectation, confrontations and everything, that will always happen, but you need to take it in a technical manner.
I have two questions, sir. One is with respect to the Industry 4.0.
Right.
So essentially, the entire industrial Internet of Things, what we call, I'm sure this is an evolved name from some of the older technologies and this thing. And we see this IoT also coming into our household to an extent. But at a fundamental level, this appears to be the same product in different forms, or the same kind of this thing in different forms. How do you view this as a business, as a market overall? This is one.
Okay.
The other is, since you had dealt right from small teams to very large teams, wanted to understand, any relation to the geographical location of these offices to the talent that we are getting. Like, for example, teams in Bangalore versus teams in Chennai, or versus teams in Pune versus. So like this, did you find in your career, some differences in talent acquisition or the talent point of view?
Sounds good.
Any relation with job?
Yeah, I think I'll try to provide my thought process on the second part first. Okay, then the technical, because see, till we were Nital, this problem was not there. Okay, because this problem was the local team itself in Pune. The clients were actually outside and were dealing with them. So that's a separate one. But once I actually got with core objects and Symphony and this thing, so operations at actually US, UK, multiple locations. And later on for myself, actually, I had a team to be managed from Pune, but all over the world. And when it becomes Symphony and Harman at multiple locations, it was China, Morocco, France, and many locations we need to actually, the teams were working. Okay. So naturally, this particular problem was definitely there. Primarily what happens, the sites which are actually local, there is a local language, local understanding, team bonding, that definitely has got its own lesson. You really cannot isolate as a complete as a technical aspects of that, saying that you just cannot ignore all those aspects and look at only technical aspects. Even the people, those who used to come and actually work in Pune, even though they are from different part of the India, they see, basically for a team to get it first, there are two aspects according to me. The first, local team there itself, they need to work as a team. They need to get bonded to each other. That is one thing. Second, when the geographical teams are across and they are working through a remote technologies these days, it's more challenging. So there, the challenge remains actually how the the partitioning of the work you can do very crystal clear, how you can define it, your scope properly. So there are no confrontation between the teams. When the team actually takes place, so we used to do actually, for example, my healthcare team located at the 4 locations. The projects were part and parcel were done at multiple locations over there. So common teams, sometimes we had to call the team at one location, and with the US and other teams, they were not able to come all the way. But actually the local teams, for example, and slowly understanding of each other, that makes actually a difference. But otherwise, even customer used to see actually a big difference. I got many customers, those who visited our Bangalore premises, Bangalore offices, they interacted with the team, and when they came to the team, Pune, and they interacted with the junior most engineer, they said here the vibrancy is completely different. And then we used to ask them, what do you think? I think it's because actually your presence actually makes a difference, because you are most of the time here and it is less. So naturally your supervisor, your this thing, how they work, so it's a part and parcel of the mix of that. That is what my experience was. But it's very challenging, there's no doubt about it. Now coming back to the first part of the question, yes, Industry 4.0, IoT, everything, I've been dealing with IoT since ages, actually, if you really want to say that. Even the SCADA was actually, my first product was a SCADA system itself, and then IoT. I do take actually Industry 4.0 training for Tata Motors and other with the local Industry 4.0 this thing, organization here. So primarily, if you look at it, where exactly the distinction? If you look at it from a lowermost point of view, as an endpoint point of view, it's an embedded system. Okay, it's an embedded system, but with a distinction. Generally, what I say. Generally, all your machines and everything, what you work, they are not personalized. They are not actually identified. There is no identity as such. If you will look at, but with Internet of Things, what has happened is the same machines and same this thing characteristics. You started giving a complete, you can say, characterization to that, so that it can be placed in a multiple location, multiple way. It can be understood. That the characteristics could be understood. It could be programmed. And then taking up advantage of actually the Internet of Things and putting it into the cloud and multiple locations. But so the scale and the magnitude is really huge. So it's a different kind of a packaging of the entire solution. Previously, the solutions were bits and pieces. So how I define Industry 4.0, this thing is on a 3 principle. First, digitalize, and then you do analysis of it. So that is how actually it goes. And when you actually design, then the scalability is actually a problem. When we used to do 2005, 2006, this IoT kind of a base kind of a system, we used to provide our own homegrown solution in terms of the servers and everything, host it on premise. Then it went off premise, and then later the cloud and everything came. Our solutions also actually completely changed later on. But so it's a complete package. What you need to design and understand in the IoT space is the basic design. What exactly the characteristics it needs something differently from a distributed point of view. How the entire data comes, and then you do a processing which is based on the entire data. Previously, used to collect the data across only one particular point and process it. So that's a difference between the two.
Since you had touched upon this evolution of or the architecture of computing, sir, just extension, we see a lot of war now between NVIDIA and Intel primarily. So one is definitely in your perspective, a strategical angle of NVIDIA, how it kind of surpassed Intel to an extent, and how this is going to impact computing in maybe the next 5 years or 10 years to come. If you could throw some light on that.
I got a very limited knowledge, to be very honest with you, Hemant. But see, primarily what happens is Intel, if you really look at it, Intel also has got a graphics chips. Intel also has got a GPU kind of an graphical units, multiple units over there. The difference between the two is Intel's chip designs and everything actually primarily focus for their own product from a PC perspective. That has been actually the distinction. In fact, you'll be surprised, but in 82, 83 actually, I saw a presentation from Nitin that time, saying that what exactly the graphics should do. Because when I did my first graphics, it was no graphics was there, to be very honest. It was a character-based displays, and from there I used to create actually carving an image using a character display and creating a graphics over there and do the SCADA system in terms of transformers, switches, and everything. So it is way back if I what I did those things. So that time I saw a video saying that how the people imagine that as a graphical will do that, and the demonstration was showing a common person on the road taking out actually the car's tire in real time with like a tape. It was to be, it can be captured like a movie, and it is fitting it up. But Intel's vision was actually that time how it can be same thing can be created on a computer so that the computer based training can be done. So you understand the difference between the video, taking a video shoot and showing it versus a computer based training, so that it can be parcelized. I can show a real time demonstration of actually the car's tire can be actually picked up, somebody putting up a jack and everything. So you can imagine in primitive those days, that is where the graphics actually started up. NVIDIA, when it actually came up in 99, 2000, around that time, I believe, because that is where it started around the same time in Pune also, if I recollect. So that time the focus was actually the graphics itself. And graphics also, they really focused from a graphics point of view, from gaming point of view. In fact, 2002, 2003, actually I purchased the graphics G or NGT or something, I forgot, G Force or something, for my son's workstation too, so that we can play graphics. So slowly what has happened, and then later on actually they came up with GPU, and the GPU to be utilized, because that was only the offline coprocessor available those days, which was utilized. So if you really look at it, the transition which has taken place over a period of time, I believe NVIDIA has got a lot more edge, because their chips are not only restricted to that. The Intel's graphic chip to be utilized somewhere else versus the NVIDIA chip using it somewhere else is a big difference. That is where exactly the Mali architecture, other architectures, what the processor which came up for your mobile and everything, they become popular, but Intel didn't come up. So Intel realized it later. But I think the age has gone. So according to me, the NVIDIA days are really strong, to be very honest. But it is still, the GPUs are still done. In fact, my ex-colleague or the Nilesh, actually what I showed you, he is actually heads the graphics division in Intel. They do wonderful jobs in actually the high-end actually graphics. But their focus is not actually like generic. I have not seen any product which takes Intel's graphic chip and putting up into the product and try to do something. They are trying to promote it now, but that's not actually happening.
Yeah. Any further questions, please?
Sounds good.
Yeah. So if at all you have any questions, you can always write to us, and we'll try to get the answer over a mail from Sudarshan ji.
Sure. Absolutely no problem. It will be my pleasure. Whatever I can answer, I'll certainly be open and saying that what I know and what I don't know. But it will be a pleasure because I saw actually the PPT shared by Harish in terms of what you people do. It's a wonderful products, what you people do. Because that is the first thing actually I just tried to take a look at it immediately.